when you get given a quadratic like this to solve without the constant at the end, so for example 7 here, without the 7 or the 8 here, without a number at the end, it's really easy to solve. So when you get given a quadratic like this, well, look what's in common. It's the x that's in common. So when you factorize this, it becomes this x 3x plus 7. Okay, so when you get given a quadratic without a number at the end, it's really easy to solve. So it's just a matter of doing this. Okay, plus 7. And by the way, this is a quadratic because the highest power is 2. So whenever you have a power of 2, it's a quadratic. If you get given this here, let's say plus 4x to the power of 3, it's no longer a quadratic because the highest power here is to the power of 3. So in this case, this is a cubic. Okay. If you get given something like this, let's say 3, you see it's still a quadratic because the highest one is x squared. Well, anyway, when you get given this, if you don't have a constant at the end, it's really easy to factorize. If you get given something like this, have a quick glance to see if you can factorize this inside your head. As it turns out, this is easy. This is relatively easy to do. Well, two numbers multiplied together to give you 20. So that would be a 4 and a 5. And you see a 4 and a 5 will immediately give you the 9x. So you know when you factorize this, it would be this. Plus 4 and then x plus 3. It's hard when you have a coefficient here that's greater than 1. So when you get something like this, then it's slightly harder. So when you get given a quadratic, have a quick glance to see if you can do it inside your head. In this case, this one should be relatively easy to do. Whereas this one here, because there's a coefficient of 3 here, it becomes harder. So here to do this, you got to do it simultaneously here. So think of think of two numbers when multiplied together gives you an 8. So that would be 1 and an 8, or it could be a 2 and a 4. And then here you got to think how you could create a 3x squared here. You could think of it as like this, or yeah, that's pretty much it. Well, if you don't understand what I'm talking about here, watch the previous 2 videos. Okay, now when you get given a quadratic like this, when you have a minus, well, whenever you can square root this and square root this neatly, you can easily factorize something like this. So this here becomes this plus, well, the square root of 25 is 5. So I immediately know this. Okay, minus 5 here. So this here factorizes to this. So whenever you can easily square root this and can easily square root this, and with a minus in the middle, you can easily factorize. So this becomes plus 5 and then minus 5. Okay, so here's another example. I know I can easily square root this. It will give me a whole number. This here will give me a whole number. And because there's a minus in between, then I know, remember, it works with a minus. It won't work with a plus. So it has to be a minus. So here I know I can square root this neatly. So square rooting this neatly will give me 3x. Okay, because 3x times 3x, that will give me 9x squared. Okay, so now I know I can do this here. What's the square root of 4? Well, it's going to be 2. So I'm going to say plus 2 and then minus 2. Okay, and the reason why whenever you can square root this neatly and square root this neatly, the reason why you can do that is because of this. If you multiply this out, this will give you a squared. Multiply this with this, it will give you minus ab. And then this times this here will give you positive AB, and then this times this here will give you minus B squared. You see, these two terms, minus AB plus AB, they kill off each other. So it gives you this. So whenever you see something in this form here, with a minus in the middle, and you can neatly square root both sides. You can always jump back to this. Okay. In the next video, I will give you some practice. Okay.